Chapter 8 Anterior Chamber and Drainage Angle. Page number 285 The Outflow Apparatus. Part 3 Trabecular Meshwork. The trabecular meshwork is a sponge work of connective tissue beams which are arranged as superimposed perforated sheets. The beams are disposed circularly in the chamber angle and extend from Schwalbe's ring anteriorly to the scleral spur and junction of iris and ciliary body posteriorly. The inner portion of the trabecular meshwork is referred to as the uveal meshwork, and the outer portion connected to the spur and closer to Schlimm's canal is the corneoscleral meshwork. Inner portion of the trabecular meshwork is uveal meshwork and outer portion is corneoscleral meshwork, that is near the Schlimm's canal. In meridional section, they are arbitrarily divided from one another by a line joining Schwalbe's ring to the innermost margin of the scleral spur, so that anterior to the scleral spur, the uveal meshwork is related to corneoscleral meshwork on its outer surface, and beneath the scleral spur, it spreads over the anterior tip of the ciliary body. The spaces of the trabecular meshwork decrease in size progressively from within outwards. The meridional width of the trabecular meshwork posteriorly near the scleral spur is 120 to 180 micrometer. The dimensions are wider in the myopic than the hypermetropic eye. Between the outermost corneoscleral trabecular sheet and the endothelial lining of Schlimm's canal is a cell-rich zone, the peri or juxtacanalicular connective tissue zone, or endothelial or cribriform meshwork. The extracellular spaces of the trabecular meshwork contain hydrophilic glycosaminoglycans and collagenous material which must influence the resistance to aqueous flow accorded by the meshwork spaces. Uveal meshwork. The inner uveal meshwork, that is 1 to 2 layers, is made up of cord-like trabeculae which interlace and taper anteriorly. The innermost trabeculae may pass from the ciliary muscle almost to the region of Schwalbe's ring. Posteriorly, there are 2 to 5 layers, and the outer layers have a more circular orientation and a more flattened profile concentric with the limbus resembling that of the corneoscleral sheaths. Posteriorly, the trabeculae may be connected either with the circular and radial muscle fibers of the ciliary body or with the meridional ciliary muscle fibers, but this distinction may be difficult to show histologically. Henderson suggested that the uveal trabeculae represented a tendinous extension of the ciliary muscle cells, the so-called pectinate ligament, which in humans generally terminates behind the scleral spur. Anteriorly, the uveal trabeculae converge to an end by joining the periphery of Descemet's membrane, the inner part of Schwalbe's ring, the corneal lamellae, or the corneoscleral trabeculae. The cellular lining of the uveal trabeculae is contiguous anteriorly with the keratocytes in the deeper region of the cornea and its endothelium. The individual cords of the uveal trabeculae have a diameter of 4 to 6 micrometer in the mid-region, being thicker posteriorly and narrower anteriorly. The intertrabecular spaces range in size from 20 to 75 micrometer. The corneoscleral meshwork. This is made up of flattened, perforated sheets, each about 5 to 12 micrometer in thickness in the mid portion and separated from each other by 5 to 20 micrometer the intertrabecular space. Anastomosing bands between superficial and deep layers ranging from 2 to 5 micrometer in thickness delineate the intratrabecular spaces. There are approximately 8 to 15 trabecular layers with a total width of 120 to 150 micrometer. Anteriorly, the sheets converge, obliterate the intertrabecular spaces and merge with the corneal lamellae and the trabecular cells interface with the keratocytes. Posteriorly, they are inserted into the scleral row. The intratrabecular spaces of the outer layers of corneoscleral sheets vary between 2 and 20 micrometer and are therefore narrower than the uveoscleral meshes. Spaces decrease in size from within outwards. Trabecular structure. The basic structure of the uveal and corneoscleral beam is as follows. Each sheet has a covering of trabecular cells, occasionally incomplete, a subcellular cortex, the glass membrane of earlier histologist Salzman 1912, and an inner collagenous core exhibiting randomly distributed elastic tissue. The collagen is oriented in the long axis of the trabecular beam. Trabecular cells. The trabecular cells are elongated in the long axis of trabecular sheet and are 4 to 8 micrometer in thickness centrally and about 120 micrometer in length. A nuclear bulge is frequently present and occasionally a cilium. Neighboring cells make contact by long cytoplasmic processes and opposed surfaces are attached by maculae adherentes and gap junctions. Maculae adherentes is a desmosome. The cells show the usual organelles including a central nucleus, moderate amount of mitochondria, rough and smooth endoplasmic reticulum, well-developed Golgi apparatus, lysozymes, pinocytotic vesicles, and vesicular bodies. They also contain cytoskeletal filamentous proteins which may play a role in altering the meshwork configuration. The trabecular cells are thought to perform various synthetic activities including the secretion of basal laminar material, collagen, and glycosaminoglycans. The cells are actually phagocytic and may contain pigment and other inclusion materials which increases with age. A number of authors believe that these cells are involved in a self-cleansing mechanism which keeps the trabecular filter clean. The trabecular cells provide a lining for the inter and intratrabecular spaces. Although the cellular surface is coated with macromolecules which are rich in terminal sialic acid residues, there is no evidence for the presence of hyaluronic acid gel filling the open spaces of the uveal and corneoscleral meshworks. Cortical zone. The cortical zone consists of a periodic acid-Gieve positive basal lamellar material which is attached to the trabecular cells by poorly defined hemidesmosomes and is otherwise separated by a lamina lucida. Its inner limit is not well defined and infiltrates the connective tissue elements of the core. The basal lamellar material in the uveal trabeculae extends into the peripheral portion of Descemet's membrane. Within the basal lamina are found clumps of fusiform, long spacing, curly collagen with a periodicity ranging from 30 to 40 to 80 to 120 nanometer. Core. The core of each trabecular sheet is formed by collagen types 1, 2 and 4, fibronectin, thrombospondin, elastic tissue, chondroitin sulfate, dermatin sulfate and curly collagen. The regular collagen fibrils, 30 to 50 nanometer wide, are oriented along the long axis of the trabecular sheets of the corneoscleral trabeculae. In the uveal trabeculae, this compact core is often surrounded by a circular arrangement of regular collagen fibrils just deep to the cortical zone. The orientation of collagen fibrils in the trabecular sheets is probably determined by the direction of pull exerted by the ciliary muscle on the uveal beams and to the scleral spur on the corneoscleral beams. In the uveal trabeculae, elastic fibers are mainly central in the core. In the corneoscleral sheets, however, they are more prominent and may show a major distribution around the core and are oriented along the long axis of the collagen fibrils. By electron microscopy, the elastic tissue shows the usual fibrillar and amorphous components separated into identifiable central amorphous and peripheral fibrillary zones. The elastic tissue imparts a recoil to the elements of the meshwork, permitting recovery after deformation. Thus, widening of the trabecular spaces on ciliary muscle contraction would be followed by a resumption of meshwork spacing on relaxation of the muscle. Figure 8.7. Electron micrograph of the trabecular meshwork trabeculae T of the corneoscleral meshwork are evident. The arrows demarcate the transition between the corneoscleral meshwork and the juxtacanalicular region JCT of the inner wall of Schlimm's canal SC. Original magnification 3000 times. Figure 8.8. Light micrograph of anterior trabecular meshwork in a 70-year-old human. This meridional section shows the morphology of uveal trabeculae UT and corneoscleral trabeculae CT. Note the rounded profile of the inner uveal trabecular sheets, shown as a star, Compare with the flattened profile of the outer uveal and corneoscleral sheaths and a progressive narrowing of intertrabecular spaces, IT. In the lateral region, PT, pericanalicular connective tissue, the arrow denotes branching of a trabecular sheath. Original magnification is 760 times. Figure 8.9. Flat preparations of the trabecular meshwork as viewed from the anterior chamber aspect. Figure A. The attachment of some uveal trabeculae with a prominent line of Schwalbe, SL. Bright field microscopy, teeth preparation, stained with methylene blue. Original magnification 240 times. Figure 8.9b. Scanning electron micrograph showing net-like arrangement of uveal trabeculae. The long axis of the deeper trabecular sheaths are oriented circumferentially. Original magnification 1350 times. Figure 8.10. Electron micrograph of the trabecular cells in an adult human eye. Note the prominent Golgi apparatus G and many fine cytoplasmic filaments F. PTS 10. Original magnification 39,000 times. Figure 8.11. Electron micrograph of a 2-year-old human eye from which the inner uveal beam has been cut transversely. The core is occupied by compactly arranged collagen fibrils C intermixed with elastic elements. Towards the periphery, collagen fibrils are circumferential and intermixed in places with basement membrane material. EN. Cellular covering of the beam. CZ, cortical zone, PTS 10, original magnification 20,000 times. Figure 8.12. Transverse electron microscopy of trabecular meshwork. Corneoscleral trabecula showing the basement membrane beneath the endothelial cover, arrowheads. The cortical zone Z and the collagen core C. The wide spacing collagen is also evident, arrows. Original magnification 30,000 times. Thank you.